Welcome, everyone. This is about web services. Uh, this lecture is going to be about something that doesn't necessarily directly relate to this week's lab, but you will be using web services next week, and you are using web services in your project. So web services, it's a big topic. It's a really cool topic. It's probably my favorite topic of the entire year. Web services are really interesting. Uh, I just say most of my career is involved in working with web services, either building them or consuming them. So we want to talk about what web services are. It's really valuable for you to understand them because you want to understand them when you go into a job interview and you're talking to somebody about APIs and web services and REST web services and SOAP web services. You want to know what these vocabulary terms are, and hopefully that will put you a little ahead of the next guy. And also, you may not have another course where you go into web services very much. So that's why this is really valuable to learn right now. So web services, what are they? It's a little misleading, the term. It's really general, web services. It sounds like services that are delivered on the web. You might remember we talked about Amazon Web Services and cloud computing, AWS. That is not the same thing. Amazon Web Services, and sometimes companies just use that term because it's just a generic term, right? But to programmers, web services means something very specific to programmers. Another way to think of them is like an API. Oftentimes is used interchanging with web services. So we're going to talk about different types of web services, and like I said, one of the vocabulary terms you can think of is APIs. Now, an API is an application programming interface. An API is a way for code on one computer to call code on another computer. And traditionally, web services was kind of the umbrella term for this technology. So let's jump back really quick to the 90s, where before this all began. How did computers talk to computers? It was really tricky. If both your computers had Microsoft technology, you could use what was called DCOM. That was distributed component object model. It was a really complex thing. It was a way to get one object in your code over as another instantiated object on another computer, be able to move that object from one computer to the next. And if you didn't have Microsoft and you were anybody else like Java or any other languages, you could use what was called Corba. And Corba had these things called orbs, and it was all about this relational model of objects and data and how you would format it. Both of these things were very complex, and it was hard to implement them, and it was not as reliable. And you couldn't just have any computer talk to any other computer. You had to be on similar languages. So there were a lot of issues with it. And then around the turn of the millennium came this thing called web services, and the first one was called SOAP. And that's still really important today. It's still used. This was the first major web service protocol. Now, that's an acronym. You don't have to remember what it stands for, but the whole thing stands for Simple Object Access Protocol. The most important word to remember is probably simple, the first one. It's simple, and that's what's so cool about it. That's what just blew everything else out of the water, and everybody started using web services to communicate because SOAP is built with, it's just simply XML. Now, XML, you might remember we went over a web.xml and Tomcat. You kind of saw a little bit of XML, kind of looks like HTML, but it's a way to format data. You can take any piece of data and format it into XML. And XML was the way that computers started trading data with other computers via SOAP. And that way I could have one computer running, let's say, C#, and I could make an object called customer, and it would have last name, first name, and customer ID and all that. I could format it into XML string, pass that over to another computer that's maybe running Java, doesn't matter. that Java computer just knows that it's going to be an XML string that looks like this. It gets that XML string of customer object, and then it creates its own instance of a customer type object on the other side in the Java computer, and now the data has been transferred over code to code. So this isn't users interacting and clicking things and passing data back and forth. This is actual code talking to code between servers. So it's a great way to pass objects and data back and forth through web services. In this case, it was the SOAP protocol that they would use. So SOAP is a web service protocol, and XML is the language or the format of data that is used in that protocol in SOAP. Now, fast forward another decade or so, and one of the problems was that this was really weighty, how many characters were in these strings. You might remember the web.xml. We were only tracking a few values, and there's tons of data in there. So XML can be very chatty, very wordy. So this guy, Tim Berners-Lee, you may have heard of, he invented the web. No big deal, right? Can you imagine that on your resume? He invented the World Wide Web. So, you just have one thing on your resume, right? Invented World Wide Web. Okay, you're hired. Pretty good resume. Anyway, Tim Berners-Lee, who invented the WWW, World Wide Web protocol, HTML, all that we talk about, that's all Tim Berners-Lee. He was getting his PhD doctorate many years later, and in this century, and he came up with this idea to try to simplify things down and try to not make it so complex like SOAP is, and to use web services in a way that utilizes already what we have built into the HTTP protocol. So the HTTP protocol, which you see at the beginning of URLs, is a format of how things are passed over the wire so that another browser can read that and communicate, or a server, web server, whatever. So he said, let's just we already have gets and puts and posts and deletes. We already have these basic functions built into that protocol. Let's just use that protocol. So he came up with this new web service type, which is called REST. And this one is key. This one really dominates the web now. Most web services are provided in REST. And you'll even hear the term RESTful, a RESTful web service. It's because whereas SOAP is extremely specific in exactly how you have to implement it, REST is very flexible. So there's many different kind of ways to do it, but you always usually inherently use gets and posts built into HTTP calls. So REST, again, you don't have to know what it stands for. I'll tell you, but it's not something you have to remember. It stands for representational state transfer, something like that. Representative state transfer. The basic idea is with the O in SOAP and the state, the S in REST, the idea is you're taking an object, right? You're taking an object and you're transferring it from one side to the other. So if I instantiate a customer object in my code and I set first name, last name on it and all that, I want to take that object and maybe I want to pass that object over to the customer, processing application that's on a different server, because my code just takes in input from a user. Then I can pass that over in a certain syntax that allows that system to instantiate into an object, and then the code deals with it from there. So the REST protocol is much simpler, and it uses JSON as the text format that it puts things in. Now, I want to show you the difference between XML, web services. In web services, I want to show you the difference in XML and JSON to show you kind of an extreme example of the differences. So let's pretend we're going to create a customer object where I'm just going to have first name and last name. So actually, I'll make it at super minimum. We're just going to have last name only and just make it super simple. So if I was going to make this in XML, I might go here and go customer. Whoops. Do that again. Customer. Then I'm going to have last name. Then I'm going to have Jones. Then I'm going to have the close of last name. And I'm going to have the close of the customer node. So if I wanted to pass a customer object, that's about as bare minimum as I can get. All I passed was one little single value, 5 characters, right? Jones, that's it. And I had to put all that wrapping on it to do XML, right? So this is like a typical example of XML. So pretty wordy. So let's look at an example with JSON. Actually, I'll do it right next to it here. So let's look at JSON here. So JSON, same example. Same data structure. We'll do a customer. A customer object with different fields. So we're going to have a curly bracket here. And we're going to do last name. And we'll put Jones. And close it out and close that other curly bracket out. And that's it. Look at that difference between XML and JSON. Look how fewer characters JSON has. So when we're talking about the web and you're talking about volume of data having to be passed back and forth over the wire between machines, we always talk about, remember, input, output, and serializing data and deserializing data, getting them into text and back into objects. All that takes time. So the more characters you have, the slower everything gets. So if I'm going to choose to send something over the wire, I'm going to choose JSON, right? I'm not going to choose XML. XML is way too long. So it was all XML up until probably the last decade, where it really switched over to REST as kind of the leader. And you can just see right here. Also, what's nice about this from a programming perspective is JSON works better into how we form Java objects or any kind of objects in regular coding than you would in XML. You can see in XML, we don't put closing tags. We don't put public class customer and then at the bottom end public class customer, right? We just have a curly bracket. So the JSON formats nicer into kind of the similar way we do objects. So as a little bit of a summary here, you can see I wrote down, this is really about computer to computer communication, code to code. You passing data objects back and forth. And very importantly, it's programming language agnostic. Right? As I said, you could have C# on one server, talk to another server that's running Java or C++ or Python or whatever. It doesn't matter what programming languages you're using. You can use this as the middle language, web services. I always use the example of the embassy. If the Chinese if the Chinese ambassador is speaking at the embassy, and I'm the French ambassador, I've got my headphones on, I'm hearing it in French, right? Everything the Chinese ambassador is saying, I'm hearing in French because we have that interpreter. This is like the interpreter. Each side doesn't need to know the other's language. They just need to know how to deal in SOAP and use SOAP XML to build in their own objects, or REST and JSON and take the JSON and build their own objects. And same with formatting them into JSON to send them out. So let's look at, there's some really cool online places where they publish public APIs where you can call APIs. Usually you have to get a key first, but usually a lot of times they're free. There's a lot of free APIs out there where you can actually call stuff. Google has tons of stuff, not just Maps API, but they have tons of different API calls. But this is site Programmable Web is just one example that has many APIs that you can search for. So for instance, I can search on weather, eventually get back some results here. And you could get real-time weather. And we're actually going to use one of these in our lab next week. So next week you are going to be programming a client to call a web service and get data back. And so we're gonna look at that in a second because we're gonna do a little bit of code. So this is one that has all kinds of just tons of different. Look at all these categories of different APIs that you can call. And usually they have you get an API key first. So this is an example of one. I'm going to show you an example in a minute from this site, which is alphavantage.co. They actually, you just get a free API key. Just right here, you can see I can just do the drop down here. I can say what organization, student, whatever. I can put in my email. I'm not a robot. I get a free API key, and you can use that API key to get live stock quotes of data. So let's look what that would really look like. So I'm going to go to this page. This is an example of what you would get back when you call this URL. Now this URL, you can see the API key is equals demo. That's because you always have to call IBM. If I change the symbol to anything but IBM, it would not work. It's just for a demo. But if you got the key, then you could change this stock quote to anything else, call that from code, and get back JSON. This is a JSON string right here, just like what we just looked at, right? It should look familiar. So you can see here there's an object called global quote, and in it there are all these different property names. They look kind of weird because it's 01 point space symbol. I'm not sure why they named it like this. It's very odd. But there is a package you'll be using next week where when you get back JSON, you can turn it into an object. You don't care how, having to try to parse the string or anything like that. You don't have to deal with that. They have packages for that usually for every language. We're going to use JSON, which is Google's JSON library that allows you to take any JSON string and turn it into a Java object, so that you can then call the properties on it just like you would a normal Java object. So it makes it really easy for coders. So you're going to be doing that next week with a weather API. I'm just going to show you here. This is another API. That was for getting a regular quote, right? Like here's the open today, the high, the low, and the current, I guess the closing price, $120 for IBM. And then here you can see they have other functions on here you can call as well. This one you can see is the function equals time series intraday. And notice all these symbols are just being called on the query string. Remember we talked about the query string. You should know what that is now with the question mark. After the question mark, you see all these key value pairs. Function equals time series intraday. Then there's your ampersand. And then it needs to know what symbol you're going to put. And then it needs to know the interval and the API key, which we're just using their demo right now. And this one, this time series intraday, gives you a lot more information. You can see it's like every 5 minutes it gives you what the price was. Every 5 minutes, I guess for the entire day, it probably goes back because the scroll bar is pretty long. And lastly, I wanted to show you, this is what you get back when you call the weather API that we're going to be calling next week in your lab. You're going to be calling this URL, and you're going to be getting back the current weather, and you're going to parse that and do some decisions on it based on what the min and max was and what the current temperature is. So you can see right now, I just ran this a little bit ago, and the temperature for El Cajon was 59.5 degrees. It says what it feels like, temperature minimum, temperature max, gives you the pressure, humidity, even visibility, wind speed. Pretty cool, and it all comes back in JSON. So as your lab next week, you're going to be doing web services next week. Not this week, because this week you're going to be making progress on your lab 2, part 1, for your lab actually. So next week we'll be doing this and getting this back and making objects out of it. Okay, so let's look at a little bit of code here and how this looks like in code. By the way, there's this cool little trick in IntelliJ. You know, you go public static void main and hit tab, and it will do the thing for you. Just a little shortcut there. I hate for you not to have to type the whole thing. It's kind of fun to get in that habit of, you know, typing it. But yeah, PSVM and then tab key will actually build the main method for you there. So let's look at some code, how we could actually call that web service, that stock one we just looked at. How do we call that and get back that JSON? We want to get back this one right here. So this is the URL we want to call. And we want to get back that JSON. So I'm going to put this here for now as a temp thing here. Now I should tell you that, sorry, I should have said this a little early in the video. You don't have to do this code necessarily. You can follow along with me if you want, but the code I'm doing here is going to be in your lab next week, so you don't need to type out all this code that I'm doing here. There's not very much code. There's a very little amount of code here, and this code is in your lab given to you next week anyway. I just wanted to show you visually how it looks when you call the stock symbol and getting some actual JSON back. So I'm in my main method here in a test web service class. Nothing special about this project. Nothing, no jars imported or anything like that. So I'm going to have to create a try. And that's because we're doing some IO calls here to another service. So I'm going to put in my catch. And for now, I'm not going to do anything. If it errors out. But in my try here, I'm going to create what's called a URL object. And you can see it sees it in there as part of java.net package. So I'm going to say URL equals, and I'm going to first add this. So I'm going to do my alt enter. Yes. So it should have imported the java.net URL. And then I'm going to say equals new URL. And this is where you pass in the website that you want to hit. Now what's interesting is we are going to take this and put that in there. However, we don't want to just, I got to put it in quotes, whoops, put in double quotes here for it as a string. So we pass this string in of the website that we want to hit, the API we want to hit. But right now we're always going to get back IBM, right? So I'm just going to show you real quickly how you could parse in your own stock there, right, to get whatever one you're looking for, just to start getting you to think about how you would use web services. So first of all, that's just setting up the URL. We're not actually calling it yet. So to call it, we need to start out by, this might look familiar, but remember the buffered reader when we did socket communication? So we're going to do a buffered reader buffer reader. Let me add this one here so it's not red anymore. Whoops, I said that's why it's not recognizing it. There we go. New buffered reader, new input stream reader, and this is where we grab that URL object we just created up above, that variable, and say open stream. And it's actually the URL.openstream that makes the actual call. Now, once I do that, it's coming back as data back into my BR variable there, the buffered reader. So now to read that, we need to do one of those while loops and loop through it. So while null does not equal string temp. Oh, whoops, sorry. Oh, yeah, we just need to create a whole string here. I'll put it right here. String as temp. So this will be the string that we're going to stream all of our data that comes back from this. All that JSON, it might come back in chunks, and we're going to stream it into this variable in this while loop until it gets all the data, all the JSON data that goes into it. So does not equal, so let me see, so stemp equals br dot read line. Okay. Now basically what this does is it looks kind of probably convoluted, but every time you're first saying string stemp equals read line, the next line. Now, if stemp gets nothing out of that, if it's done and it's null, then null does not equal null will not be true, and the while will stop. So this will keep going as long as there's more lines to read here and to put into stemp. So we are just going to create a string. We'll create it up here for our service return JSON. And we'll go ahead and fill that here. So we'll keep adding in whatever stemp is every single time until it is null. And I did plus equals, but I didn't initialize it. That's why it has a problem. You can see here I didn't initialize it to an empty string, so it's null. And then right here I'm trying to do plus equals on it, but it doesn't even equal anything yet. There's nothing to plus onto. So I'm going to set this to empty quotes so that now I can add on every single time the next value that comes in onto this. And remember, it's just going to be chunks of that JSON. So if we go back and we look at it, this is what we're going to get back. But it may come in chunks. It might be like, you know, this part comes in, and then this part comes in, and then this part comes in. It might be just chunks of this data coming back from the internet, coming back through, and we're kind of chunking that together kind of from that stream of data. Okay, so once we do that, you can imagine what we do. And do the last thing is we want to go ahead and print out our result. JSON returned, and that will be our service return JSON. Okay, so if everything works, we're going to get back IBM's JSON, and then we're going to go ahead and print that out. So I'm going to try to run this and see if it's working. And hopefully at the bottom here we'll see it print out. And there we go. So we get the JSON returned, and you can see this is the start of the JSON, is that right there. And you can see there's global quote, there's one IBM, there's the open price, the high price, etc., etc. It just goes on and just print it out all in one. Now again, this would be really difficult, right? If you were going to have to try to parse this string and try to get the values you wanted, if you wanted to act on that data in your code, be very tricky. So that's why I said JSON will come in very handy, because JSON, which stands for Google's JSON library, the JSON library, which is just a jar file, you include it in your project just like you did the servlets jar file that you've done before. I give you the jar file and you just include it in your project, and you're able to, you create objects for something like this down here. You create an object with the properties, and it will take the JSON and fill in an instance of the object for you. And you'll see that in next week's lab. Next week's lab, like I said, you're going to be dealing with the web service, or the weather web service. Now, I just wanted to show you really quick. If we had a string, we want to make this dynamic. we set this to IBM, let's say, but obviously we could set that to any stock symbol we wanted to. I just wanted to show you how easy it is. Obviously I could just go in here, take out IBM, end quote of that string, do a plus sign, add in my stock variable, plus sign, and then start the quote again. So in here you can see I dynamically added something into the URL so that it will change based on what I set the string as. In your lab next week, you're going to be getting a symbol from the user, and you're going to, when you bring that variable in, you're going to then add that variable to the URL so that it calls specifically that one. So this should work just the exact same way. I'm going to hit play again here, and we should get the exact same quote of IBM if it works properly. And here it comes, it's calling the server, and there it is, IBM. So you can see I just made it dynamic by breaking this out here, and that's what makes it really powerful on the coding side, because now you could fill in any kind of thing you wanted and you could get different quotes back if you had a valid API key. This is demo, so it only calls IBM only, but most of those APIs I told you about, you have to get your own kind of API key, and then you can use them, a lot of them, most of them freely. So hopefully this gives you real basics on kind of making it dynamic and how code can call the other code. Now again, we're dealing with JSON here, so this is a RESTful web service. So what we just did here, as simple as it may seem, is we actually made a REST web service call to a web service, to an API, to a REST web server, obviously offering a web service. So we were the client in this standpoint, and they were the server. If we go back and look at this, again, very beautiful drawing with the perfect boxes, you'll remember that we were talking about how there is a browser that acts as a client, makes a request, and gets a response back, right? Well, one thing I didn't talk about much when we were dealing with this is we just kept talking about that there's Java being ran, or JSP, on the server side. But this request might have been a web service request, which in what comes back might be JSON. So we put in here HTML because that's what we were dealing with before when we were just talking about it in a basic way, but it might come back as JSON. JSON or HTML, right? So if it comes back as JSON, you might be calling a REST web service and getting back JSON and dealing with it that way. So the response from a web server, what you're calling, depending on how you're calling it, you might be calling a web service, but it acts in the same way. So when you build a servlet, you could be building a servlet that is like a web service. And that's actually what you're going to be doing in the first part of our project. You're actually going to be building a web service. So back to this drawing, this is our architecture for project 2. Remember that you submit something in here, you get it over here, the drone starts moving around, and every time the drone moves, it calls this guy down here, your drone data service that you're going to develop. And actually that's going to be part of your lab this week. Your lab this week is going to have you make this JSP, which again, it's already mostly built for you, this one and this one. You're just going to go in and add code to certain areas. So you're going to create the form, but the rest of it in there is there. And same with the drone sim. There's a lot of code there, but there's just a few little parts you have to add in the drone sim JSP page. These are both JSP pages. So for your lab, you'll see the doc walk you through that. You'll also see that the lab wants you to do 3 out of 4 pieces in this servlet. You don't have to finish it, so you're not making a finished product this week in your lab, but you're actually getting points. It's a 5-point lab, but you're actually getting points for getting started on project 2 part 1, which is pretty cool. So you're getting credit for doing something you're going to have to do eventually anyway for your project. So you're going to do this one, you're going to do this one, and then in here you're going to do the first 2 parts, and then you're going to attempt the 3rd part. The 3rd part has you tell the drone where to move next. You go from one spot to the next spot. So whatever spot gets passed in, you try to figure out the logic of what would be the next spot. So if I get passed in an X is 5 and the Y is 3, you have to try to figure out what is the next one. Do we increase the X by 1? Do we increase the Y by 1? We always start in the upper left. and it's always serpentine, meaning the drone always goes like this around the rows. So you're going to have to figure out, given any X and Y, you always know what the next X and Y is. If I tell you the drone is here, you can look on there and go, well, it went like this, and then this, and then this. Oh, if it's here, then the next one is here. So that's what you have to figure out in code. You're being handed an X and Y, and you have to figure out what the next X and Y is. Now, again, I just want you to attempt it. I don't expect you to get it right. Very few people ever get it correct when they make their first attempt, because that we're going to go over next week in a lecture. I'll go through the code with you, and we'll do it together, and you'll get the logic for how to do that. But in this week's lab, I just want you to make an attempt at it, to at least try to see if you can think through how the logic might work. So you're doing this, you're doing parts 1, 2, and 3 in here, but 3 is just making an attempt. So you're not going to have anything you have to deploy or have to build or have to run. You're really just getting this stuff going and get part 1. I consider all this part 1, right? All this on the left side of the dash line, part 1. So you're just getting going on it for this week's lab. And then next week's lab, you'll build an actual web service lab with the weather web service, which is pretty cool. That one's fun. So back to this diagram and the weather and the web services. This call, every call, this is acting like a web service. That's why, specifically why I put the word service at the end. And that's why I put this word service at the end of this one. Both of these are web services. This happens to be a web service that my JavaScript code that I wrote for this JSP page that's in there, it calls this every single move of the drone. It calls, says, hey, where do I go next? Hey, where do I go next? Hey, where do I go next? And it passes in the X and Y every single time into this servlet. And so this servlet that you're going to be coding acts as a web service. So you're making a web service, just like the web service we just called for the stock quote for IBM. That's what this is like. It's acting like a web service that provides back data. And you're actually going to be passing this back in JSON, which we'll talk about in next week's lecture, how that JSON looks as well, how you pass back the data in JSON and where to go next. Then this call where, remember, it then passes that data also to the cloud to be put eventually in the database in the cloud for every single move of the drone, every single spot. Well, this is a web service as well. This is one that's living in the cloud, and your web service is calling another web service, which is very common in programming. So your code is going to call this web services code. So here you're going to be providing another web service. That's in part 2 that we do later, part 2 of the project. So you have 2 web services that you're building here, which is really great, again, for a potential employer. When you're talking about this as a good story later of what you built, you can say that you built web services, and they were REST web services that took in data and passed back JSON. And that's what these 2 things are. They're acting as REST web services. So it's integrated into our project, this idea of web services, and they are using indeed REST. And so hopefully this gives you kind of a good overview of what REST web services are and web services in general, including SOAP. With this, hopefully that makes a little bit more sense of what you'll be doing in the lab next week, as well as how you'll be using that same code that you do in next week's lab. You'll be using some of that code in your project. So it'll be really helpful once you get familiar with the code next week. It'll make that part of the project easier as well. And that's it for web services.